I've already added the code in the project for the trace listeners. We just need to open up the program.cs file and uncomment the line that calls that code. This line calls a static method in a class that I've added here called custom debug config. You can put this anywhere. I just put it at the root of the project. There's a using statement at the top for system.diagnostics. Then there's just the static method. First, it sets a string to the location where we want to write the text files. If the directory doesn't exist, this code will create it. Then the code creates some trace listeners. The first is the default trace listener. Because we're going to clear the collection of trace listeners, we could leave this one out and there wouldn't be any messages written to the output window. We could also configure this trace listener to write its output to a text file by setting the log file name property. Next, the code configures a console trace listener. That will write messages to the console that's opened for ASP.NET. Next is a text writer trace listener, and that will get created in the folder we specified above. After that, there's an XML writer trace listener, which will get written to the same folder. And finally, we configure an event log trace listener. And in the constructor, we're passing in the name of an event source. That's just a way that we can find our messages in the default application event log. I have to use the name of an existing event source because the ASP.NET process doesn't have permissions to create a new one by default. There's a green squiggly line here that's warning us that this event log trace listener will only work on Windows platforms, which makes sense because .NET 6 is cross-platform and Linux doesn't have an event log. Next, the code removes all the existing trace listeners from the collection on the trace object. Remember that the debug class uses the trace listeners on the trace class. The debug and trace classes are very interconnected. Then we add each of the trace listeners to the collection, and finally set autoflush to true. This will write the contents of the buffer automatically, without having to call trace.flush each time. That's mostly important for the XML trace listener. Let's run the app now. When the app opens, I'll go to Reports and run the report for February again. And let's run the month after that, because I know there's data there. Okay, let's take a look at the file system. I've just hit F5 to refresh Windows Explorer. This diagnostics file folder is the one that the code created. Inside it, there are two files, the output of the text writer trace listener and the output of the XML writer trace listener. Let's open the text file. So there's the message that was written in the onGet method, including the write and writeLine messages that were concatenated. Then the expense entries are formatted into columns because of the padding that I used. Where the expense price is different from the adjusted price, there's a line that precedes the expense to indicate that. And back in the code on the reports page, we can see the debug.writeLine if statement that wrote that message. Okay, what about the XML file? Let's try to open it. It says the file is being used by another process, which is the ASP.NET process, so we'll wait until we stop the app. The output window has the same messages, and remember that's because we added the default trace listener to the collection. Let's take a look at the console window. The messages are written here too, because we added the console trace listener to the collection. How about the event log trace listener output? I'll search for the event viewer on this Windows VM, and let's open it up. By default, the trace listener writes to the application log. This column is the event source, which is basically a category to help us filter messages. We could create our own event source for the application and then reference it in code. But remember, I used the .NET runtime as the event source because it already existed. Back in the event viewer, the messages were written as information messages. And each write and writeLine statement got its own entry in the event log. So depending on which trace listener you plan to use, you might organize your debug messages more efficiently. Okay, let's go back to Visual Studio and stop the application. And we actually have to kill the process by closing the console window in order to release the lock on the XML file. Now I can open the XML file in the folder on the file system. By default, it opens in Visual Studio. Let's format this by highlighting all the code with Ctrl-A and then formatting it with Ctrl-K followed by Ctrl-F. Now we have an XML trace event node for each write and writeLine statement in the code. The formatting doesn't make much sense for XML output, but just like with the event log, you probably won't be writing to multiple trace listeners when debugging. You'll pick one or two and format the messages in a way that makes sense for those trace listeners. Before we finish here, I just want to show you how debug messages are left out of the code when you compile with a release configuration. Let's close this file. And let's change the configuration to release. And I'll delete these two files. These shouldn't get written again, because even though the code will configure trace listeners, the debug, write line, and write line if statements won't be part of the release. Let's run the report again. We'll do multiple months again this time, so it's the same test. And as expected, no files were created. And in Visual Studio, there were no debug messages written to the output window or to the console. So system.diagnostics.debug gives you a way to include code to make debugging easier, and that code will get removed automatically from the release version of the app. In this module, we looked at advanced features of breakpoints, including conditional breakpoints and trace points. And you saw how to use the debug class to output tracing messages to different destinations. If you'd like to know more about the business rules design pattern I used in this module, you can check out this course by Steve Smith in the Pluralsight library. In the next module, we'll look at some more code features to help with debugging, and also how to use logging providers to log diagnostic messages in your deployed code, which can give you information to help track down bugs.